Good morning. I am Aubrey, and you are here for an episode of Aubrey Logical. Alright. So I'm going to have some of my music playing in the background, so I hopefully don't get flagged for copyright, because it's my shit. Okay. Here we go now. I am Aubrey. Oops. So our first problem is back to integration by parts. So first thing we do again is find what we're going to choose as u and v. Now these represent functions, and right here we have functions. X is a function, and that is multiplied by the function of ln of x squared. That's a function as well. So we have to pick one of these functions to be u and one of these functions to be v. But one of these functions is going to be v prime. So it's the derivative of v. So usually we want to pick the logarithm to be our u if given the option, because it is going to simplify when we take its derivative. So let's just go ahead and name our two functions here. F of x is equal to x. G of x is equal to the ln of x squared. Okay, so let's go ahead and find their derivatives now. Well, okay, just kidding. This actually is the derivative. So therefore, we're going to find the antiderivative of that one. Okay. So we have the derivative is equal to x. So blank, let's see here. Y prime is equal to blank. Alright, y prime is equal to x. So y, this is gonna be what this was before. So that means we're going to get its antiderivative, which means we're gonna add 1 here and then divide by that number. So let's just go ahead and do this. So we have x. Right now it's x to the 1. To get its antiderivative, we're going to add 1 to that. So it's going to be x to the 2. And then we're going to divide by the 2. And that gives us our antiderivative of x. Next, we need to find our derivative of the ln of x squared. Now, the derivative of ln of u is equal to u prime, or wait, I mean u times u prime. No, just kidding. It's 1 over u times u prime. Okay, so we've got 1 over x squared, and then we're going to take that times the derivative of x squared, which is, to take a derivative, we decrease this number by 1, but then we bring the old number out front, so it's going to be 2x. Okay? Now, simplifying this expression, we've got 2x over x squared. Further simplifying, we can get rid of the squared and that x, and then we're left with 2x. So now that we found the antiderivative of x and the derivative of ln of x squared, we can go ahead and put them into our functions, into our formula, excuse me, and make this smaller. Okay. I forgot to buy more oat milk yesterday. So today I'm drinking a Americano. Not that good. That's okay. Not that bad either. Alright. So for our u, like I said, we're going to pick the ln of x squared. Its derivative is going to be 2 over x. Seems crazy, but that is it. And then our v prime is going to be x, and then our v is going to be x squared over 2. So now let's go ahead and write out what our formula is. So the formula for integration by parts is u times v minus the integral of u prime times v times dx. Okay. Oh, I guess I should, here, let me see. Let me redo this. I'm sorry, I did this wrong. Yes, we know, it's all in your head. Alright, so that's our formula right here. Let's box it. Why not? Oops. Alright. Let's go ahead and plug in. We've got u. Damn, Spencer's got such a good voice. Okay. And we're going to take that times x squared over 2. So that's times minus the integral of u prime times v times dx. So we can simplify this as follows, and then we can simplify this as well. So we're going to have 2x squared over 2x, and then we can just go ahead and we're left with 2x. You see, because the 2x and the 2x cancel, so there's 2 copies of 2x on top and there's 1 copy on bottom. So it's essentially, God, I don't know what to do. What if we have 5 squared on top and 5 on bottom? If we did that, we would have 25 over 5. Let's see here. If we just got rid of this 5 and that 1, we would have 5. 25 over 5 is 5. Okay, anyways. I don't know why I did that, but anyways. So that's just to kind of illustrate that we have 2 copies of this on top. So we can just get rid of one of the copies here, and this is our only copy, so we're just left with 2x. Let me rewrite this. dx. Okay. Let me make all this smaller. Because I didn't leave myself that much space. Come on. Fucking piece of shit. Alright. Now, let's go ahead and rewrite. A lot of rewriting going on in these problems. Okay. Well, this is pretty easy because the integral of 2x, the 2 is going to come out front, and then we're just going to have the integral of x dx. So, the integral of x, so this is an antiderivative, so we are adding a power and not subtracting a power, so it's going to be x plus 1, so that'll be x squared over 2. So now we have 2 times x squared. Let's go ahead and cancel those, and then we're just left with x squared. And the dx is gone because we integrated. It's interesting. I don't know if this is right. Let's check our work real quick. What's our problem again? We got, oh shit. Okay. X times the ln of x squared. Okay. And that's how you're wrong. Yeah, that looks right. Okay, I don't know what I did. I'm so confused. Alright, I don't know what I did wrong, but I definitely did something wrong. So I think I'm gonna need to do integration by parts twice. Oh my god, I gotta change the song. This is fucking annoying. Get over it. No. There we go. Okay, that's better. Fuck, I don't know what I did wrong, y'all. This feels right. Unless I did, it's u prime times v, right? 2x squared over 2x. Well, I guess I can go back to the first time I did it and see what I did differently. Okay. So this shouldn't be 2x. Oh, I fucking forgot to do the first thing. Okay. Oh my gosh. Okay, now I feel silly. Hopefully, making this mistake now, I won't make it on the damn test. Alright, so my first issue was I did the whole thing wrong because I want to use logarithmic properties. So let's just do it all over again. This is music by yours truly. Alright. We got fucking
sky. Still need to blend it. Can see those lines. Are we almost finished? Can't see the line. As God's my witness.
I lost my mind. So the rules of logarithms, I guess, say that we are able to take our 2, which is up here in the exponent, and we can move it in front. So it would be x times 2 ln of x, which we can just write the 2 in front of it all, and then we can actually just bring the 2 out in front of the integral. So alright, let's try this again. Now, our 2 functions are x and ln of x. So, explain it again. Yeah. It's nice to listen to some of this music because I can see if I want to put any of it on my music stream now. Okay. Alright, let's try this again since I fucked it up. But hey, better than here than on the test. Alright, so we have got... So ln of x is going to be g of x, so 1 over x is going to be g prime of x. Let's make x our f prime, so then we're just going to have x squared over 2. And now we can plug in again. Yeah, I guess I should call it differently. Okay, so this is v prime. That's u, that's u prime, that's v prime, and that is v. Okay. Now, we can plug in. So we have u times v, which is going to be x squared over 2 minus the integral of u prime times v. So I wouldn't have done it right. If I would have just done the first step in the first place, then I wouldn't have done this. I wouldn't have messed up. Okay. I'll do the next one. Nope.
Flowing down like water.
No. Okay. Sweet. Now we're back. So rewriting our expression. Alright, so the way we were able to do this is you can take a constant out of an integral, so we have 1/2, so that just comes outside. And then we're left with x squared over x, which reduces down to x. And that's how we ended up with what we have. And the reason we want to do this is because now it's really easy to take the antiderivative of x, right? So we have 2 times Oh, this is a good song by my friend Hal Safar. I don't know. I'll probably get a copyright flag on this one too. Who knows? All right.
Time may be fading, and I can't be everything to everyone.
Okay, so the antiderivative of x is going to be x squared over 2. So we have another 1/2 to pull and add with that. So let's just go ahead and make this 1/4.
Until you walked in this party, I've forgotten how it felt. When you say you were better with me, but now we know it's all for show, and it was nothing I could see.
Okay, did I get it right now? 2 times 1/2 of ln of x times x squared minus 1/4 x squared plus c. Cool. And that is correct now. So, the takeaway from this one is that anytime you see an ln in your problem, just start thinking about your rules. So there's one he had us memorize where it's basically, if it's b to the a, it's equal to e to the a times ln of b. And then, anyways, there's a lot of logarithm properties that can help you manipulate your equation to get it how you want it, to make things easier for you. Okay. Alright, sorry Hal, I'm over it. Alright. Cool. Just got a bunch of short little tracks by me now. Alright. This one's gonna be tough. Because I do not remember the formula. I'm trying to think. The arctan formula. Okay. Alright, what am I gonna pick for u and v prime? I think for u we're gonna pick arctangent of x, which I think after we take the derivative is gonna be like 1 over x squared plus 1? Let's check. Derivative of arctan. Oops. Dang it. Hey, it's Spencer. Probably gonna get copyright strike on this shit too. Alright. Yeah, I don't want to get copyright struck. Okay. So this is what we want. Copy and delete. Back to our file. Oops. So I was pretty close. I mean, it would technically be right. So just to fit this form a little better, let's just write 1 plus x squared. And the reason that I know that this is right is because it's saying that the derivative of arctangent of u is equal to 1 over 1 plus u squared times u prime. So our u variable in this equation is x. So it's 1 plus x squared, And then the derivative of x is just 1. So obviously that doesn't change it, and we can just say 1 over 1 plus x squared. All right, cool. That's interesting. Okay, on to our v prime, which is going to be x, and our antiderivative of x squared over 2. So now we can plug into our formula arctangent of x times x squared all over 2 minus the integral of 1 over 1 plus x squared times x squared over 2. Let's go ahead. Let's see, do I have any? I have a little more room. Cool. So if we pull the 1/2 out here, it's going to be x squared over 1 plus x squared. Which we can rewrite this as x squared over 1 plus 1. So 1/2 times derivative of x squared is going to be 1/3 x to the cube. Derivative of 1 is going to be x. So that should give us 1/6 x to the third plus 1/2 x. Alright. I think I did that right. Okay, let's try again. Ah, okay. Another tricky one. Okay, so the way we're gonna do this now is we're gonna add 1 to make this expression equal to itself, and then so we don't actually change our equation, we're going to then subtract. Oops. Minus 1 over 1 plus x squared. So essentially we haven't done anything to our problem except for make this easier to work with. So
for making it to old age in this world, minimizing on the cold days in this world. Need the sun, need the warmth,
1 minus 1
need
over
balance, need love,
1 plus x squared.
freedom, and I've seen a lot, to be honest, but we've just begun to scratch the surface. What's my age now? What's my purpose? What's it mean? What's the point of it all? I don't know. I don't honestly even care anymore. It's just a breeze right through my hair. What's in store? It's not my business till it's there. I can't afford.
Okay.
My sanity's my only prayer, but it doesn't have to be. Life's wonders are plenty each morning. I can't believe I wake up in a dream. I almost lost everything, but now I am back to green, back to my regularly scheduled program. Been
Son of a
holding my
bitch.
tongue.
Every time I do that.
Done saying things when I don't mean them with one.
Okay. Let's rewrite our equation here now that I think we have it finished.
Another way to better fine tune to fit with the scheme of things, to take in the scenery,
to clear out your mind and just breathe, oh so easily, to manifest your dreams. That's the theme and that's the reason we are gathered here today in the shade right beneath the trees.
I don't know. I don't honestly even care anymore.
So this should be a plus, I believe.
My hair, what's in store? It's not my business till it's there. I can't afford. My sanity's my only prayer.
Minus 1/2 x plus 1/2 arctan x. Yeah, that's right. Totes. Cool. Aww. Yep, I gotta change this one too. Copyright. Yeah, this is the one I made. Okay, here we go. On to the next one. Damn, what a fucking doozy. So the trick to that is to just know what arctangent's derivative is. So 1 plus u squared times u prime. Okay. Okay. On to the next one. So let's go ahead and pick what our u and v prime are going to be. So here it doesn't really matter which one you pick because e to the x is going to be e to the x always. It's never going to be anything else because its antiderivative is e to the x and its derivative is e to the x. And for sine, we're just never going to get rid of a function. It's never going to just turn into a constant number. It's going to go flip back and forth between sine and cosine, sine. So antiderivative, it'll flip between sine to negative cosine to negative sine to positive cosine to positive sine to negative cosine. Yeah, it's just going to keep flipping back and forth between sine and cosine. So it doesn't really matter what we pick here. So let's just do e to the x. Derivative is e to the x. Sine of x. Derivative is negative cosine of x. So we can plug in e to the x times negative cosine of x minus the derivative of e to the x times negative cosine of x times dx. Boom. Now this is integral of by revolution is what it's going to be, because we're going to end up, let's just go ahead and call this I. The integral of e to the x times sine of x dx is called I. So we're going to end up getting back to this, and I'll show you in a second. So we can, oh yeah, I got to pick another u and dv. So we can go ahead and get that negative out of there, and we just have a positive there now. Picking our u and our v prime. We just go ahead and pick the same thing. E to the x, e to the x, cosine of x. Okay. Cosine of x turns into sine of x. So now let's do rewriting. We've got e times cosine of the x plus. Okay, now we're gonna have to write this in parentheses, and we're gonna write e to the x times sine of x minus the integral of e to the x times sine of x times dx. And look at that. Same thing as right there. So this is convenient for us. Let me make this smaller. Okay. So this is convenient for us because now we can rewrite this as the following. So this integral is equal to negative e to the x times cosine of x plus e to the x times sine of x minus I, which means we can then add I to this side, gets rid of it over there, and brings it over here. So now we've got 2 times the integral of this, and then we can just divide our 2, and then our final answer is going to be 1/2 times negative e to the x times cosine of x plus e to the x times sine of x plus an arbitrary constant number. And that, my friends, should be our answers. Cool. Okay. Onward into trig integrals. I don't know how this is gonna go, y'all, but we're gonna give it a shot. These are actually the problems I was assigned. So let's see if I can do them. So this one should be pretty easy. Cotangent squared of x. It's the same thing as I think it's 1 minus cotangent squared of x is equal to cosecant squared of x. Let's see here.
They ask me, how are you gonna do that? They say, better just get yourself back to work now. I tell them this life is a trap, absurd how we are just built to collapse. No way there. Not gonna do
Alright, that's what I'm looking for.
my own course. I'm not gonna follow their map.
I believe in me and in need of my plan. This is what I need to know. Okay. So I did it slightly wrong. I just missed my sign. So this means our identity for cotangent is going to be cosecant of x minus 1. But wait a minute, this isn't even going to help us. Because why do we want cosecant? What would that do for us? Nothing. Anyways, okay, so this is all true, but irrelevant. What we're going to want to do in this instance is we're going to want to see the fact that cotangent is equal to cosine over sine. So this is equal to this. Now, let's see, do we have a function and then its derivative on top? So let's see, if we pick u, so u prime would be sine of x, and then u prime would be cosine of x. So it's technically 1 over sine squared of x times cosine squared of x. Which I guess isn't quite our derivative because we don't have a... So this, if it was that was our function, then it would become that. I'm confused. Let's see here. Oh, well now we can use identities. Okay. I got it. Alright. Duh. Alright. And we can look up here. So we can rewrite this as sine squared of x minus 1 over sine squared of x. And then we have 1 minus 1 over sine squared of x dx. So we can now integrate these separately. The integral of 1 is just going to become x, and the integral of 1 over sine squared of x is actually going to be one of our identities, or not identities, but it's going to be on our formula sheet. 1 over sine squared of x. Oh my gosh. Again with the copyright. Fuck me. I'm trying here. Okay. Alright. Alright, here we go. Alright, so 1 over sine squared of x is going to become cotangent of x. Would be negative, but it's already positive. So I think that might be our answer. Seems a little too easy or something. Let's double check. Interesting. Okay, so I wrote it just a little differently this time. So I don't know if that would be right. because cosine squared of x plus sine squared of x is equal to 1. So would cosine really be 1 minus sine? Yeah, it would. Okay, well that's still right then. So I think negative cotangent of x minus x plus c is actually the same as positive x plus cotangent of x plus c. That's so weird. Yeah, I don't know if those are the same, but makes sense to me. Alright, this is tough. So for this one, I think we're going to want to split it up into secant squared of x times secant of x. So we're not doing integration by parts here anymore. Let's go ahead and write our identity. I don't know if I can take this derivative. I don't think I can take these derivatives separately. I don't think we can do that. It's too bad we can't, because this would become tangent. Let's see what I did here. So they do have us doing a u dv situation. So another integral by parts. Okay. How weird. How would this make any sense? I don't think I did this right. Alright, well, I guess the writing is on the wall, folks. I need to practice my trig integrals, because I don't know what to do. It's been fun getting this far with you. But yeah, I gotta call it a day and go work on this shit some more on my own. Thank you so much for watching me do math. It's been fun. Have a good day. Happy Saturday.